Hello my dear students, good afternoon. Now let's continue the class about solid state. So what we discussed yesterday means regarding types of crystal systems and Bravais lattice we discussed. There are 7 types of crystal systems and total 14 Bravais lattice. Bravais lattice classification is based on positions of atoms. Okay? Different positions of atoms gives different Bravais lattice. Now what we will discuss means radius of particular atom which is present in a unit cell. Okay, so in simple cubic for atom, what is the radius? For in FCC, in face centered cubic, what is the radius? In BCC, what is radius as well as bond length, or bond length what we call nearest distance between two atoms. Nearest distance, how you will have the distance between two nucleus. Which kind of atoms? Neighboring atoms. Who are those? Neighboring atoms. So between neighboring atoms, what is the internuclear distance? That is called D. Okay, that is called nearest distance or bond distance. Okay, and what is the relation between edge length as well as radius? We will see now. So now what we will discuss here, radius of atom. So after radius we will discuss packing efficiency of atoms. Okay, so those will let's see one by one. So first radius of atom we will consider, this is R. Okay, so what is first we will discuss means radius in simple cubic. Radius in what's it? Simple cubic. Okay, so radius I use in simple cubic. How atoms are present, you know this. So this is cube. Like this you are having a cube like this, and here you are having two atoms, because simple cubic means where you will have atoms only at corners like this. 1, 2, 3, 4, 5, 6, 7 and 8 corners you will have. So you are having only corner atoms. Suppose this is one corner atom like this, and this is another corner atom like this. So you have two corner atoms. So this is what you know already. This one here to here is called edge length, correct? So I am drawing like this again. Here to here it is A and this is B, and here you have one nucleus around this. And this is another nucleus. So B I will draw here. And like this, and see this will be edge length. This is A and this is B, and separately I written here like this. So what this A to B, this A to B is called nearest distance or D. D is what? Nearest distance or else bond length. So half of the distance means from here to here, this distance what we call as the radius. So this radius is how have a relation with edge length. We will see now. This radius having some relation with this edge length. AB is edge. Correct? This is one edge like this. You can consider two atoms here also, not a problem. And you can consider two atoms here, or you can consider two atoms here, not a problem. So any edge you can consider, because all corners only atoms present. Okay, in simple cubic. So come to this. So I written very clearly, A to B is the bond distance and this is radius. So what is the radius? Therefore you can say radius. So radius is equal to, you can say 2r, because here to here 1r. Sorry, radius is equal to simply A by 2. Because A is equal to 2R. Why A is equal to 2R? Here to here is R, and same way here to here is R. This is another R. So R. So A is equal to 2R. So radius R is equal to A by 2 for simple cubic. So this is for what? Radius in simple cubic. Got it clearly? So there is nothing here. What is the internuclear distance? Internuclear distance, or else bond length, or nearest distance. Nearest distance is what? Simply A. So nearest distance is D, we will represent. That D is equal to A for what? Simple cubic. For what, sir? For simple cubic. But so now let's see radius in face center, FCC. So I'll write individually so that you won't get any confusion there. Okay? So this is about the radius in simple cubic, A by 2, and the nearest distance D, or bond length or bond distance. What is the bond distance? The internuclear distance between two adjacent atoms. What are the adjacent atoms in this simple cubic? Corner atoms. Correct? Now let's see what is the radius. Radius in FCC, face center cubic. So now we will discuss about that. So what you have, FCC means radius in FCC, face center cubic. Where you have atoms in FCC, you have atoms in all corners as well as face center atoms. So radius in FCC to have, first of all, we have to draw that what? Crystal lattice like this. So here you are having, here I am drawing this crystal lattice like this. Okay? Yes. You are having like this. So here you have atoms like this. All corners 1, 2, 3, 4 and 5, 6, 7 and 8. And you have atoms at this particular face centers like this. So like that 6 faces you are having. Here 1, 2 and 3 and 4, 5 and 6. Actually this is face center. Now forget about these faces. Only one face center atom I am considering. Listen carefully everyone. Okay, this is very important for us. Okay, so this is what, here you have atom, here you have atom, here you have atom. So there are adjacent atoms, only simple cubic is this and this you can consider, or this and this you can consider. But whereas in face center you have to consider these two corner atoms as well as this face center atom as considering face diagonal like this. What is diagonal? Face diagonal. Suppose this is A and this is B and this is C. So what I am considering, I will draw like this. So A, and here you are having B, and I will draw one more. So for just clarity I am writing like this. So this is A and this is B and this is C. Okay. So triangle I consider. So triangle ABC I am considering. Okay. Right angle triangle. So here you have atom, and here at face center you have atom, and again this is corner atom. So these I am considering again like this. So you have atom at corner like this, face center atom is like this, and here you have another corner atom like this. So how many you have like this? So here you have one, and in middle and like this. So if you want, I'll consider here also. So 1 and 2 and 3. So this is corner atom and this is corner atom, and in middle you have face center atom. So like this you have a radius R. See radius, you must observe everyone. Here to here one radius, and here to one another radius, here to here one radius, and here to here another radius. So you have like this radius. So 1, 2, 3 and 4, because this is R. Understanding everyone? Triangle I will write here. So this is R, this is R, this is R, and this is R. So AC is equal to 4R. AC is equal to what, sir? 4R you have. Getting what I am saying? So now, by considering this triangle, right angular triangle, triangle ABC, you know, you are very good in maths. So what you can say, from triangle ABC, you can say that AC square, this AC square is equal to AB square plus BC square, right? Correct? What is AB? Here AC is 4R. You have like this. AC is 4R. What I am doing, understanding? I am giving relation between radius as well as edge length. What is edge length? A. Okay. So what is AB here? AB is equal to A, because I am considering cubic. Okay. And Mr. BC also A. Face centered cubic. Cubic means I told na, all three edges are same. Face centered cubic I am considering. So AB is equal to A. That means this AB is A and this BC also A. So what I can write now, therefore, AC is equal to root AB square plus BC square. So AC is equal to root, this is A square plus A square. So root 2 into A, that is AC. What is AC actually? What is AC? AC is called face diagonal. What is this? Face diagonal. What is face diagonal now? I told you in previous also, this is called face diagonal, and here to here is body diagonal like this. This is called body diagonal. Here to here, if body center atom is there. But here what cubic you are considering? Face center atoms. Means corner atoms as well as face center atoms you are considering. Because you are giving radius for FCC, face center cubic. So face diagonal formula is root 2A. It's very important. What is face diagonal formula? Root 2A. Okay? Because very important. Sometimes calculate face diagonal, they'll ask you. So that's right. And now, what is AC? AC means what I told you? 4R. So therefore, I will write here. Therefore, AC is equals to root 2 into A means 4R is equals to root 2 into A, correct? So radius is equals to root 2 into A by 4. So R is equals to A by 2 root 2. Very important. Remember this one. For numerical solving, useful. And to understand packing efficiency also, you must know this radius formula. So this is very, very important for us. This is the radius for whom? Radius of atom in FCC, or for FCC simply. Radius of atom in FCC you are having R is equals to A by 2 root 2. This is for face center cubic. So very simple. Now R is equals to A by 2 root 2 you have. What is the nearest distance now? Nearest distance or bond distance D is equals to simply A by root 2, because nearest distance is always 2R. Nearest distance is always 2R. That means into this R, 2R. So 2 into R. It's 2 to cancel, so A by root 2. Understand here? Nearest distance is always 2R. So that means 2 into A by 2 root 2. 2 to cancel. So what is the nearest distance? Therefore, nearest distance D is equals to A by root 2. Nearest distance of atoms in FCC is A by root 2. This is for whom? For face-centered cubic. Why I was arranging simple cubic understood? At one place, radius in FCC you will have. So what we did? We calculated radius, and for FCC we considered one triangle here A, B, C. So I was considered 3 atoms, 2 corner atoms and 1 face center atom like this. These 2 are corner atoms, and in middle you have face center atom. So this AC distance is equal to 4r. Why also I told you here. So from here to here, don't consider this to this also, because AC means from here to here. This r we won't consider. So this also will consider, means it will be 6r no sir, better no sir. Don't say like this. From here to here one, from here to here one. Understanding? R like that. So R, here to here R, 2r, 3r, 4r like that. So AC you have, and phase diagonal also you have formula. What is phase diagonal formula? Root 2a. Got it clearly? So this is about Mr. radius in FCC. Radius is where? FCC. Now let's see radius in body centered cubic BCC. Same story, but you will consider body center atom. Face center atom won't be there. So radius in BCC, body center, radius of whom? Radius of atom. Otherwise you will whose radius, or it is radius of atom. Radius of atom in BCC, body centered cubic. Let's see now. Okay, so now we have to arise this, and we have to draw again for BCC, body centered cubic. Get it? So what is BCC? You have idea already. BCC means you have atoms at all corners as well as one body center, exactly center of the particular cube, body center of the body. Okay, that is called what? Body center. So let's have that particular diagram also. So I will draw that. Again, same story. So I am considering again cube like this. So here I am considering atom. This is one atom and this is one atom. So you have 3 atoms. You understanding here? This is one. Okay, what is this? Corner atom. And here exactly you have a body center atom. And here you have what do you have? Another corner atom. So I can consider like this. From here to here. Getting? Here to here. Okay. So next, like this. And here I have, because this is not a triangle, so we have to consider like this. Triangle. Okay. So what you have again? A, and this is B, and this is C. In triangle we have to consider to have this radius, because here you have R, because here is one atom and here is another atom and here is, so you have a body center like this. So can I consider like this? So it, wait, shirt. So you have 3. So A, and here you have a B, and here you have Mr. Okay, so and this is one. Got it? This is A and this is B, and here you have C like this. Got it? So where you have atoms? You have atoms at all means corner. So this is corner atom, and in middle you have a body center atom. and here you have another third one. Understanding? So here you have just a minute. Support extra more ink. Sorry for the disturbance. So here you have radius. Here to here you have R, and here to here you have R, and here to here you have R, and here to here you have R. Same. Now AB is equal to 4R. Same story. So this is corner atom. In middle, this black color, you have a body center atom. Okay, and these two red color are corner atoms. So AB is equal to 4R. So now if you consider, no need to consider 3 like this, A, C, this one something like D, by knowing that what is this, like that you have no need to consider, simply directly you can have, okay, this triangle. Otherwise this side will consider, this side will consider, this side will consider, no need, because AC is what you know. What is AC? AC is what? Face diagonal. Already you know. So AC is equal to what? Root 2A. This also you know. AC. Simply remember, AC is equal to what? This root 2A. Now consider this triangle ABC again. So what you can write? AB square is equal to this AC square plus BC square. Same story. Okay, but you are considering this one like this. Understand here? So AC square plus BC square. So AB is what now? Root AC square plus BC square. So what is AC? You know, AC is root 2A. What is BC? This BC is up here because this is one edge. BC is one edge. So what is BC? Simply A. So what I can have now? AB is equal to root 2 into, so simply, yeah, root 2A whole square plus this is A square. Because AC square now. AC is root 2A. So root 2A whole square. So what is AB therefore? AB is equal to 2A square plus A square. Got it? Therefore what is AB here? AB is equal to root 3 into A. Because square root cancel for A. So root 3A. AB is equal to root 3A. So what is AB? This AB is called body diagonal. Body diagonal is called. So body diagonal you have. What is the face diagonal formula? Root 2A. What is the body diagonal formula? It is root 3A. Simple story, and it's very, very important for us. So body diagonal formula. Body diagonal formula is what, sir? Root 3A. Face diagonal formula, root 2A. Understood, sir? So what I am considering? I am considering body center cubic. So I was considered 2 corners only. Don't think like that, sir. In body center there are 8 corners. No, sir. Oh my God, you consider only 2 like that. Don't think. So body diagonal atoms I was considered. And if you want, I can write all these corners like this. 4, 5, 6, 7 and 8 corners you are having like this. But I am considering this to this. So to have Mr. AB, I must know what is AC, I must know what is BC. So AC is face diagonal. I told you this is face. This is face diagonal AC. So face diagonal AC is equal to root 2A I have, and AB is root 2A square plus A square. So AB is equal to root 3A because 2A square plus A square, 3A square. So root 3A, root will cancel for A. So body diagonal formula is what? Root 3A. Face diagonal formula is what? Face diagonal formula is what? Root 2A. Getting what I am saying? So these are very important. So now you have, what is AB? Why 8 is 4 are understood? Because atoms are present at two corners and one body center. So therefore 4r is equals to root 3 into a. So r is equals to root 3a by 4. So in previous what you have? For simple cubic r is equals to a by 2. For FCC r is equals to a by 2 root 2. Now for BCC r is equals to root 3a by 4. This is for whom? This is for BCC, radius of atom, instead of for better to use in pieces. Radius of atom in BCC r is equals to root 3a by 4. These all formulas are very important. We have to solve many numericals. Come directly they can ask radius. So radius means you have like this. Even in density radius required sometimes. Because density means mass by volume. Volume is a cube. So a they won't give, radius they will. So from radius you can have a. Getting what I'm saying? To calculate radius, to calculate density, to calculate body diagonal, to calculate phase diagonal. These formulas are very important. Believe me, these are very important for us. So what is the radius of atom in BCC means r is equals to root 3a by 4. This is very important for us. And now what is the nearest distance? Nearest distance you can call it as d. In BCC you can call just remove 2 because is equal to 2r is equals to what I told you. It's a 2r. So 2 into root 3a by 4 and simply root 3a by 2. So nearest distance d is equals to root 3a by 2 for BCC. Nearest distance between whom? Between two atoms. Nearest distance between these two means this one and this one. So nearest distance means here to here. So this is r and this is r. So 2r is equals to nearest distance or not? So nearest distance in BCC is equal to 2r. So 2 into root 3a by 4. So distance is equals to root 3a by 2. Hope you understood about radius of atom in simple cubic as well as face center as well as body center. Okay, let's write all these at one place. So let's have a screenshot and write down about all these things. Okay, completed. Now let's have all these at one place. All these means what? These phase diagonal formulas and body diagonal formulas all at one place we can have right now. Okay, so what is phase diagonal formula, tell me? While arising this, root 2a. What is body diagonal formula? Root 3a. What is simple cubic? Simple cubic. Radius a by 2. Okay, I'll write all those. First I will start with this. Phase diagonal formula, root 2 into a. There is no root for a, remember this one. Few people will write root 2 into a. Sir, answer not coming, sir. Why answer will come? There is no root for a. So phase diagonal. What is the formula for body diagonal? Body diagonal is equals to root 3 into a. Again, here also there is no root for a. A means what, you know? Again tomorrow don't ask me, sir, what is a? So here only I will write better. This is edge length. So you have formulas for face diagonal as well as body diagonal. Now what is Mr. All formulas, simple cubic and FCC and BCC. Okay, for BCC, how many types of, how many effective number of atoms? Effective number of atoms I represent with Z. And what is the radius? And okay, effective number of atoms, how many for simple cubic, radius, and last and final, that is nearest distance in brackets d, or else this nearest distance only called bond distance. Bond distance or bond length. For simple cubic, how many atoms are there? 1. FCC, face centered cubic, effective number of atoms for what? 4. BCC, 2. Why? Even in finding density, you must know how many effective number of atoms are present. So this is very, very important. So effective number of atoms in simple cubic one. So effective number of atoms, effective, I was written only effective number of atoms. If you want, you can write effective number of atoms we represent with Z. So 1, FCC 4, BCC 2. Radius just now I was given. So radius is R. R is equals to A by 2 root 2. So what is A I was given? Here, radius is A by 2. Here radius is A by 2 root 2. Okay, here R is equals to just root 3 A by 4. Just all multiply with 2, then you will get nearest distance. So what is the nearest distance for simple cubic? These are very important. This table is very important. Okay, so all these you will have at one place. And here nearest distance is nothing but edge length only. Here nearest distance is equals to A by root 2. Here nearest distance is root 3 A by 2, that's it. So this is about simple cubic, face center, body center, radius as well as what? Mr. Nearest distance. Next, all packing efficiencies means atoms are present in a cubic crystal, means they are regular arrangement. So when atoms are like this, so this particular unit cell, what is the packing efficiency? Means how much area, how much percentage of area occupied by these atoms. This is particular area and this is particular area occupied by atoms, and this free space between atoms, this free space what you have, that is called void. Very important about voids. We have octahedral voids and tetrahedral voids. Those all we will discuss at one place. And here what I said understood. These are the area occupied by particular atoms, and here what you have gaps. I am putting here dots like this. You just observe. And here this is void, this is void, this is void, this here void, void. Void means free space. So in particular unit cell, some area was unoccupied. Only some area only occupied. That area how much occupied by atoms in a particular simple cubic or else in FCC or else in BCC, we call that as packing efficiency. Packing efficiency means the particular space occupied by atoms in unit cell, that we will discuss in our next class. So simply today you just remember about void.